Thanks, Bob. I appreciate that kind introduction. So, yeah, I kind of got into the whole home energy thing in the 80s when I was a young architect. I think I did it even before I got, when I was still an intern and before I got my license. I, American Institute of Architects came out and said, "Hey, architects, you're not doing very well. Department of Energy thinks we're going to go haywire here if we can't do better buildings." So I kind of went, yeah, we got to be able to do this better. And soon after that, I did my first Energy Star home, and for a friend of mine out in Waller County. And so that was a pretty interesting start for that. And so I've kind of been working on it ever since. So here's, I'm also getting, finally halfway decent, I think, at doing presentations. It took quite a few years of being obtuse before I can kind of, get to the point. So I'm hoping that y'all will appreciate, what we have here in clear talk instead of, architect speak or something like that. So without further ado, here we go. Home Energy 101. Does residential energy matter? Okay. So let's take a look at these two bars. This is ERCOT, and this is from ERCOT. And basically what they're showing is when on the left is a mild day, and on the right is an extreme day. So this is a winter impact. And you can see that residential just goes crazy. Everybody's firing up their heater and doing everything they can. Large commercial goes down in percentage, so does small commercial. They go down in the percentage of energy being used, and residential is, just completely going haywire. Okay, so that's winter. And then, did I miss summer? What the heck? Okay, well, anyway, summer is very similar. So then this is like lately, the high risk and elevated risk potential for insufficient operating reserves in above normal peak summer conditions. Okay, and so you can see that we're right in there, compared to the rest of the country. Nor are we alone. Okay, but so we're in high risk for this. And then this was a New York Times article. I loved it, and I've been incorporating it for a while now. This is the the 90s and into the 2000s average of days above 100 degrees. Okay, and you can see that Houston is in the gray zone, and and this is we should realize that we had 2011, which is right after this was done. We didn't have that many 100-degree days. We had unbelievable number of 90-degree days. Okay, everybody knows that, but people may not realize we didn't have that many 100-degree days. So this is what it's looking like according to all the doomers, of which I am one of. In a few years, we're going to just be crazy with probably 10 to 25, maybe even 25 to 50 100-degree days during the year. Dallas is going to be very unpleasant. And you can see the colors there. All right. So there's all kinds of stuff on the internet. I just found this residential energy consumption survey. So here we are looking at air conditioning expenditures per household. And you can see that the Texas average, kind of top right next to the map, is 460 compared to 299 for the average in the United States. And of course, you've got Alaska contributing to the average in the United States. So, but yeah, something, again, we all know, but there's data out there for anybody who wants to pay attention. As far as states, we're third. Okay, we have the third highest air conditioning load. We're behind Arizona, right? Okay, so wait a minute, Steve, where's gas? Well, okay, so we use it for heating, we use it for water heating, we use it for cooking, and it's very cheap. But from a health standpoint, it's leaking into your house. And it's also leaking methane into the atmosphere from wellhead to your appliance. Okay, gas is leaky. Nobody wants to admit it, but it is. So what can you do about gas? Well, you can obviously turn your thermostat down, take shorter showers, or cook less. Okay. Now, on the positive side, whenever we have an outage, power outage, the stove works. So hey, it's not all bad. And again, it's real cheap. So there's gas. All right. So here we are back to just looking at energy consumption. This is the average annual electricity consumption by type of home and census region in 2015. Okay. So on the left, the bars are all homes. Then we have single family detached, single family attached, apartments, 2 to 4 units, apartments, 5 or more units, and then mobile homes. Okay. Now the green bar is the South, okay, which we're in. So again, it's just kind of backing up that we're using a heck of a lot of electricity. Not so much gas, but we're using a lot of electricity. So there you go. 16,000 kilowatt hours a year in single family detached houses. All right. So here's summer, I don't know how these got separated, but anyway, here's the summer weather impacts compared to the winter impacts. You can see it's the same. Residential just completely goes off the rails. Small commercial goes down and large commercial goes way down because they're not using that much energy when it gets hot like the houses are. Okay. So sorry for beating that into you, but you just need to be aware of that. All right. So where are we using our energy? All right. This is a great little graph from the EIA. So top of the list is air conditioning. Then we have space heating, which again, this is average across the country. So there isn't that much space heating in down here, but there's still space heating. Then there's water heating, which is huge, lighting, which is huge, refrigerators. Okay, people don't think about the refrigerators, and maybe some people do, but there's that. Then TVs and related. Okay, so they're kind of right up there with refrigerators. Then there's your clothes dryers. Then ceiling fans, which are a very good expenditure of energy. Okay, ceiling fans are fantastic. They can cut down on how much energy or air conditioning you're doing. All right, and then we have air handlers for heating, separate freezers for crying out loud. Just be thinking about that. And then there's cooking, dehumidifiers, microwaves, and it just goes on down. And then unfortunately, there's all the things that they can't really aggregate very well. They throw it into all other miscellaneous, and that adds up. So here we are. Anyway, just, factoids, things for people to kind of keep in mind. All right. So then here's another pie chart in the west, south, central. And you can see, here's the space heating thing again. So it's not like there's no space heating going on. Other is gigantic. And then you can kind of see the relationship between AC, water heating, and refrigerators, which you have kind of somewhat of a control over. All right, so the lesson for today is the DIY home energy audit. All right, this is available still, even though I've retired. My website is still up, and you can download this 4-page guide from codegreenhouston.org. All right, everybody see this? You can get there. So when you scroll down, you will see the DIY home energy audit, and you click read more, and you can bring it up. So here we are, we're bringing it up.
I gave you 2 big end pieces.
Yeah, you had big pieces. Don't need any more.
It was so big you had trouble eating it in one bite. You had to bite 2 bites.
Okay, yeah, it looks like we had a little
The sausage, a little sausage snack. It's low carbs.
okay, so somebody might need to mute themselves. At any rate, we're looking at the DIY home energy audit, and one of the most important things is right off the bat, add up all your energy bills for the past year. That's why I put a star there. So how many kilowatt hours did you consume and how many for the highest month? Okay, so you just need to kind of have that in mind as you're looking around your house or apartment or what have you, to just see where you are, how much energy are you using. Are you doing it because your energy bills are out of whack, you know, or you just want to use less energy and be a good citizen? All right. So here are some averages for you. This is something that I did for the American Institute of Architects when I was doing a you know, residential energy CEU for them. So the average home size, you know, in the hot, humid area is slightly over 2,000 square feet. Your average annual energy bills, okay, is an average of 155 a month or $1,800 a year. Your average annual AC is about 27%. All right. Your average annual water heating is about 17% of that. Your average hot, humid home energy, annual energy usage in kilowatt hours is about 15,000 to 16,000. So 15,819. That's the average. And this is in the hot, humid, not including Alaska. Okay, so these are kind of decent numbers to use. So if you take the average home size and divide by the annual square footage, take the annual energy use in kilowatt hours, divide by the home size, you get 7.82 kilowatt hours per square foot. So if you have a smaller house and you want to compare it to the average, you can go to per square foot and then see where you are with your bills, okay? And so then we have this EUI, energy use index. Don't worry about that so much. This was for AIA. And you can also see the 92 cents per square foot energy bills. And that's using 11 cents a kilowatt hour. So this is if you really want to get into the weeds, here you go. All right, there's the averages. So then getting back to the home energy audit, you want to walk around the house and check for air leaks, okay? And here's this really good little checklist with some check boxes, and you can just get your head in the game and walk around your house and look at that. Then check to see if you got weather stripping. That's very important because you get a lot of air leakage around doors and windows. Then go on the outside of your house and look for areas where two different building materials meet, looking for cracks and gaps. And then check for any holes. You know, you never know. You could be, you know, there could be leaks around a faucet or leaks around an electrical outlet or something like that. So just look around the outside of your house as well. Then we want to talk about insulation a little bit. Is there any way that you can figure out what kind of insulation you have in your house or your apartment or what have you? You may not be able to. Do you have a hatch or ladder to go up into your attic? Okay, if it's in the conditioned space, you know, is that a big hole in your insulation? So that is a huge problem if you're not thinking about that, okay? So any kind of attic openings you want to take a look at, attic vents, you want to make sure that the vents to the outside are not blocked, and all kinds of interesting things. You can look for your water heater. Perhaps you could put some insulation around your water heater. And then water pipes, are they insulated? That could also help during a freeze if they're insulated. So be looking for insulation. This was a slide that's probably the best slide I ever had during my entire career with the city because I presented it to the inspectors and it kind of gave them a new realization of what they ought to look for before things get covered up. So these are the various levels of installation for insulation, okay? Grade 1 is very good. Grade 2, there's gaps, and grade 3, there's a lot of gaps, okay? So this is what's interesting about it, especially in your attic where you need a high value of insulation. So if you have an R30, let's say, code minimum now is R38, but you know, let's just say an R30 with no gaps equals R30, and with 4% gaps, it equals R13. R13 is like 4-inch insulation in your walls. That is awful. So inspection of any insulation, if you're going to do any remodeling and you're going to do any insulation, you want it to be installed properly, okay? Because if it's installed improperly, it's getting itself worked down to worthless, and that's not what you want. All right, back to the home energy audit. You want to look to electronics and appliances. Are there any that are, burning electricity when they're turned off? You look into that. Are your electronics and appliances more efficient? Like, are they Energy Star rated? Your refrigerator, if it's really old, it could be using a heck of a lot more energy than you'd like. So these are all just thoughts. They're not like, hey, go do this. All right. That's why you want to do an audit and then prioritize and do what you're able to do. So windows, putting solar films on your windows is an incredibly effective mechanism in this climate because there's a lot of radiant energy getting in through your windows. All right. Just to be aware of. Plumbing, if you can use less water, you're burning energy to heat your water. So if you can use less hot water, okay. And then of course, everyone wants to use less water, but it's hot water that's the big one. So then finally, the last page is the energy saving tips. Let's take a look at those. Whenever you can use task lighting instead of, lighting the whole room. That's a good idea. Turn your lights off when you're not in the room. All these things that you already know. Okay. Turn off the TV when no one is watching it. So, there you go. It's a nice list of things that you can do if you feel like it. Okay. And they're legitimate suggestions. Each one is not going to just fry your brain and wow, that was it. Okay, man, I'm using a lot less energy. It's, like how many of these can you deploy? So that's kind of the question here. All right. Then, let's take a look at, and then here's right before we get to the pie chart, ceiling fans. There's the spiel on how much more, comfortable you can be with a low consuming device. Ceiling fans are not much more energy use than a light bulb. Okay. So, that's the way to go instead of turning your air conditioning thermostat down. All right. So anyway, just so you know, these pies show you since AC is a huge, usage of your energy bills, your walls are not your big thing. It's really the attic. And notice how big your windows are. And then there's leaky infiltration, which there was practically a whole page on walking around to check for air leaks. And then there's your appliances. Now, some of these appliance usage, there's nothing you can do. You aren't going to be turning your refrigerator off to not be on, for a couple hours a day. That's insane. So there's a certain amount of sunk costs or sunk energy usage in your appliances, but some appliances use much more energy than others. And some use energy when they're turned off. So look into that phantom load kind of thing. So the most control you really have is your attic and your windows. Well, infiltration too. Like let's be looking at weather stripping. Okay. So those three, the green, the red, and the dark blue are the big ones. That's what you want to prioritize looking into. Okay. So meanwhile, just so you know, air conditioning, here's another one of those slides that show how much air conditioning is being used in the various climate regions. So ours, we're using the most. We're using even more than, actually overall expenditures than Arizona, believe it or not. I just went to Arizona, got a grandchild in Arizona, and wow, it's nice compared to here, even though it gets super hot. So here's the various states of air conditioning per square foot, okay? Ton of, or square foot per ton, sorry, square foot per ton of air conditioning, okay? Texas is the second worst, right? The worst happens to be Pennsylvania. Don't ask me why. It's ridiculous up there. But Texas uses the most tonnage or least square foot per ton. Square foot of house per ton of air conditioning is a good rule of thumb to see how efficient your house is. So, you know, if look at Georgia, my gosh, and when you have that much more square footage to be cooled off by the same size air conditioning unit, that is really good and saving you money. So you might want to look into that square footage per ton at your house. All right, so keep in mind, factoid, the larger the AC unit, the more it costs and the more it costs to run. That is a fact. You can, you know, delude yourself about, oh, I really love my size of unit. The bigger the unit, the more it costs and the more it costs to run. The smaller units cost less to buy and they cost less to run. Fact, just keep that in mind. All right, so meanwhile, here's a couple of things like, you know, don't complain. If you got a second refrigerator, a separate freezer, okay, and you're burning more energy, just, you know, hey, do you really need that? Just, you know, be looking at that. All right, so is everything clear so far? It's not one thing. So then this is just kind of extra above and beyond. This is what architects use to determine if their design, the house, is going to meet the energy code. Okay, so this is kind of interesting, and I think you would like this, even though you're not an architect and may be scrambling to understand if you could, you know, understand this. But basically, we've got, I've circled the ceiling, and notice they put in, the architect put in the square footage. Then we have the walls, typical wood frame, okay? And you put in your insulation R value. And then there's the floor. This one's a typical slab on grade, and you're gonna have no insulation. And so what it's adding up is UA. See the column that says UA. So when you get done, you're going to be looking at that. Not that you have to internalize it, but I'm just telling you, you know, how the program works. So your typical basic code minimum, R38 in the attic, R13 in the walls on a slab with the windows, you know, with a solar heat gain coefficient of 0.25, okay? That gives you a 0.8% better than code, okay? 0.8%, so that's like code, all right? There you go. Down at the bottom, you can see the maximum UA, and that's what the program is adding up. That's it compares it to the code. So the maximum UA is the code. Your UA from what you put in is 614, and that's how it comes up with 0.8% better than code. More than you ever want to know, but like you're gonna love how this continues. So now we've gone to a pier and beam. Okay, we don't have a slab. So that means you've got some cavity insulation in your floor, okay? Same thing, everything else is the same. Ceiling, walls, windows were the same size house. We've just gone to, now we put it up pier and beam. Notice now it's 6.3% better than code. So we had a 5.5% improvement. Okay, now let's go to better windows. We went from a 0.25 solar heat gain coefficient to a 0.21 solar heat gain coefficient. It went up by another 5.2%. Now we're at 11.5% better than code. Okay. Now, next one, let's go to continuous insulation on your walls. This is where you would put like a foam board all the way around your house before you put the siding on, before you put the brick on. So you've got cavity insulation. We went up to 15 instead of 13. And we put a continuous foam board around at 3.2 R value. Now we just went up 11% from where we were, and we're up to 22% better than code. So what is this doing? This is keeping your air conditioning in and the heat out. And that's kind of the name of this game. And this is what you want when you buy a house, or if you're going to revisit doing your house or remodel your house or something like that. You want to always be looking at the envelope. The envelope separates you from the outside. Okay. All right. Now we have a structural insulated panel scenario. you would probably never do this. It's advanced enclosure technology, but you know, this was for architects, so I wanted them to know how much better things could get. So that's another 9.5% better than what we just looked at, and we're up to 32.1% better than code minimum. Okay, so this gives you a feel for, yes, there are things you can do, especially if you're building from scratch. And this wasn't even including you know, equipment stuff. So what do I do at my house or my apartment, and what is a good upgrade? Okay, so 1, do the audit. 2, attic insulation is huge. 3, weather stripping is huge. Remember that pie chart? Okay, window film is huge. Then it comes down to your air conditioning system. Okay, change AC or a duct replacement, and you would want to do a manual J and a manual S investigation to right size your AC unit and to right size your duct work. Okay, and then finally take a look at your water heater and your refrigerator. So these are kind of in my recommendations of a priority. Do the audit. The biggest bang for your buck is attic insulation, weather stripping, and window film. As you can see, they're all kind of right in there because they're about the same size pie chart, you know, pie slices. And then, you know, if your AC is just like Gonzville and you've been thinking about redoing it anyway, that's going to be gigantic. It's actually going to go to number 1. It's going to be the biggest thing you can do. But it's insane to replace your AC units with no attic insulation. I mean, that's insane. So that's why it's down there at number 5. You want to take care of your envelope and then change out your AC, not the other way around. Okay? All right. Thank you for joining today's class.